going to discuss about heat equation. In heat equation, we have the concept of heat distribution, where we can apply mathematical modeling. We apply the mathematical modeling concept in order to understand the heat distribution in a rod. Okay, you take a rod, so how the transfer of heat is happening, how to understand that by using mathematical concepts. Okay, so you can see this question. So here the temperature for, so here this is your heat distribution function. Heat distribution functions where x denotes distance, t denotes time. So u of x comma t is the solution what you are going to find. So then, so you will find the heat distribution solution. So how to find and what are the steps involved and what are the boundary conditions, initial conditions you have to apply. So in order to derive the solution, that is what we are going to see here. So this is the heat equation. This is the heat equation. So dou u by dou t is equal to alpha square dou square u by dou x square. So this is the heat equation. Okay, this is the heat equation. You can name just some name A. So what is happening here? So in this concept, what I am telling is you are taking a rod. Okay, you are taking a rod and you are heating this rod on both sides, on both the ends. Let us mark A, B from the end A and B. So you are marking, you are heating this rod in the ends. Maybe A at some temperature, B at some temperature. After a certain duration, what will happen? The heat will transfer from left to right and also from right to left. So in a particular time period, a steady state condition may provide. Steady state condition may provide. In the steady state condition, maybe the temperature will coincide on both sides, all the same. In all the total distance, the temperature will be the same. So after the steady state condition is arrived, you can stop heating the rod. You can stop heating the rod and you can leave it to reduce the heat. So when you stop heating the rod, what will happen? The temperature will go down. The temperature will go down. Here we do two types of experiments. One experiment is the temperature going down to 0 degrees Celsius, and the other one is temperature going down to some particular value. Maybe in the initial period, this is in the A side, that is in this corner 80 degrees Celsius. When you stop giving heat, this is becoming 40 degrees Celsius. Then you are doing some experiment. So instead of that, two types as I told you. One is you are stopping the heat, heating this rod, so that the temperature entirely becomes 0 on both sides. That is maybe the entire rod. That is one kind. The second kind is you are checking for a particular temperature. First, initially it was 80 degrees Celsius, and you are going to do an experiment when it reaches 40 degrees. Maybe the other side 60 degrees. Some particular temperature can be applied. So here in this problem, I am going to explain you how the first type of operating condition, that is after the steady state condition is arrived, you are just stopping heating the rod so that the heat completely reduces to 0 degrees Celsius. In that situation, how to find the heat distribution? Got it? It's very simple. This is the heat equation. Okay, this is the heat equation. So in the steady state situation, your dou u by dou t will become 0. In the steady state situation, the question itself will be mentioned when steady state condition provides. Okay, so your dou u by dou t becomes 0. So if your left hand side is 0, the right hand side can be equated to 0. So when this alpha square goes to the other side, what happens? Because when this becomes 0, 0 by anything is 0. So you have this result. Dou u square u by dou x square equal to 0. So I want u of x comma t. I want u of x comma t. That is, I want u of x comma t. So here it is dou square u by dou x square. In order to remove differentiable concept, derivative concept, what you do? You have to integrate. Alright. If you integrate, the derivative will be eliminated. So here, since it is dou square u by dou x square, you have to integrate twice. So when you integrate for the first time, you will get, when you integrate dou square u by dou x square for the first time, you will get dou u by dou x with a constant x. When you differentiate once again, that is when you integrate once again, this will become u of x. So the constant again. When you integrate the constant, what happens? Along with the variable, you get along with the variable. So ax plus a new constant you get. it. Because you know the concept that is whenever you integrate, when you will integrate, you will get plus c. Then the integration limits are not there. Am I right? So here, so this steady state concept is very important when it comes to exam. So wherever you go and you see a question paper in boundary value problems, then you sure question with steady state condition. Okay. So after doing this integration, after doing integration for twice, and just 2 times, you will get this result. U of x is equal to ax plus b. So from here the problem starts. That our overall discussion starts from here. Okay.